Hey, Ice Cream, how are you? Been some time. Hello. Not too bad, not too bad. How are you? Hey, Marvel. Hey, Tenzin. It's a very good question. So I thought I'd leave it a bit open today, just in terms of whatever you guys want me to do. So you can submit some questions in, again, at my email address. I do have a collection of, well, yeah, maths, of course. I do have a collection of questions we can do if not. Thanks, Nithika. I mean, technically speaking, you could watch this then go and watch the video afterwards, right? Do both. Yeah, if you guys want to submit stuff in, you're more than welcome. $3D trick. Let's see if it's here. Split screen, watch both. Okay, that's pretty advanced. Volume. Are the GB going to be similar to grade boundaries? So the way they do grade boundaries is that after they've marked all of your papers, they basically split it up into percentages. So the top 10% of marks will get grade 9s and then so on. So it kind of depends. The IGCSE Pentagon question. I don't think so. So I think they're trying to get it similar to 2019, but they can't really say that without having the actual grades yet. I mean, you might not have. You might have done decently. You don't know, right? You never know until you get that grade back. And yeah, 60 out of 80 isn't bad if you got 60. It's fine. I'm sure you didn't do that badly. Yeah, if you want me to like go through a paper or you want to submit in questions, you're more than welcome to. If you need my email address, I can give that as well. Okay, that is actually kind of bad for the frequency polygon thing, but it's fine. We can improve and get better. What do I think would be in paper 2? So, actually, give me a second. I have the paper 1. I have a copy of it. I'm gonna look through that just to remind myself what came up in paper 1, and then I'll make my predictions for the next paper. Give me 1 second. I sent it to someone recently. Ah, I see. Damn, that was my old thing. Someone sent me the actual paper. I think it was on Discord. 1 sec. And I can copy it over here. As soon as it processes anyway, and then we can get into it. Or is it going to crash? Yeah. So this is the stuff. This is the paper one. Hopefully I can show this. And let's see what came up. So we had the division and everything. I believe, if I remember rightly, no vectors have come up. So in paper 2 or 3, there's definitely going to be some kind of vector. Okay, whether it's vector proofs, like in terms of geometry, or whether it's like column vectors, that's left to be decided. I think there needs to be more probability as well. Minecraft, you keep watching. Oh, 3D trig came up, so that means it won't. There shouldn't be any more 3D trig, so you can kind of rest easy on that. The inequalities was very hard. I went through this with one of my students. Rationalizing shouldn't come up. Circle theorems, that's good. Exam style vectors, yeah, I do have a whole video on that. And I have gone through quite a few vectors, but I don't mind going through some more vectors if you guys want, if you guys want to submit a question. So if you want to email in a question, just email it here. And we can go through it. I got one of the answers for the last question. So, okay, if you want to know where the marks come from in this question, is if you got one of them, you should only drop 1 mark. Right? So you should get 4 out of 5. Okay. So if you got everything except the very last step, you should get 4 out of 5. What do you put the integer form? Integer form? Oh, as in this number here, like here. So, okay. So for this question, keep in mind that these are the 2 inequalities we have, but we want something that satisfies both of them. Oh. Yeah, it'll probably be 4 out of 5. Probably be 4 out of 5. Will I drop marks if I put an equals and less than sign? Yeah, you'll drop marks. So if you solved both quadratics, but you didn't put any inequalities, that would be 3 marks. So if you solved them, 3 marks. Inequalities, getting these 2 inequalities is the 4th mark, and then the 5th mark would be for getting the last bit. Hey Ma, how are you? So yeah, that's it's not the end of the world if you didn't get the actual final answer. It's not an easy question. It's not an easy question, but solving the quadratics will give you most of the marks, okay? That's what you have to keep in mind. This is definitely a very, very hard quadratic inequalities question. Very hard quadratic inequalities question. Normally they just give you just the quadratic itself. In fact, I did go through questions like this, but I didn't have the and, right? So we went through questions where we did one or the other, but not both. Can you go over the third question? Yeah, so is that this one here? The carrot and tomato one. Interesting. I can go through this question if you want. Yeah? Okay, sure. So if I just rewrite the question, what we'll do is we'll ignore the answer just so we have To be fair, this isn't an easy one either. So I'm not surprised that you may have fumbled. The first step would always be to rationalize the denominator. So you're going to rationalize both denominators by timesing by the surds. Right. Don't you think they nice us by giving you a quadratic inequality? Quadratic inequalities are nice because they're worth a lot of marks. The reason why I don't think it was nice is because it's two quadratic inequalities at once. And you have to do the overlap between them. So yeah, 3 root 3 times 4 would give me 12 root 3. 3 root 3 times root 3, so 3 root 3 times root 3. These two basically cancel, so we get rid of the root, so that's just 3 times 3, which is 9. Over... I mean, this would be FOIL, right? Do you think probability equations will come up? More probability is definitely going to come up. Whether or not it's an equation is different, you know? Because there has to be more probability marks. There weren't enough questions in this paper for that to be done, so to speak. Yeah, you're going to times them by each other. You want a question where you have to make a recurring decimal into a fraction? Yeah, that'd be pretty good. That doesn't actually come up every single year, but it might do. Who knows? Yeah, so Rome, I think that's a very very common problem, is that I think a lot of people try to make the denominators the same first, but you have to rationalize first. I found AQA paper 1 very easy, but I was wondering if your grade 9 videos are fully comprised of grade 9 questions, or is it just high level questions? Yeah, so it's high level questions. Okay? So they're not all grade 9, so to speak, but they're the hardest that each topic could be, if that makes sense. So it's the hardest ratios, hardest probability, hardest vectors, hardest equation of straight line, or whatever. Okay, because not all topics are grade 9. Minus, whoa, I almost made that mistake there. 26 root 3 over 39. And then you subtract those, so you get 13 root 3 plus 27. Not 13, sorry. That's meant to be 10. I promise I can count. Whoops. No worries. Where do I start to do better on paper 2 and 3? Best thing to do is just to continue practicing as many questions as humanly possible. But the main thing, by the way, the main thing, when I say do questions, right, that's not the only thing you need to do, right? You need to then mark them, and then not just mark them, is where you go wrong, you need to actually understand why you've gone wrong. Okay? Like, you actually need to understand why the mark scheme does the thing it does. A lot of the times, and I used to do this when I was in school as well, is when I read a mark scheme, I'd say, oh, that makes sense, and then I'll just go on, right? But I need to actually understand the whole point. Okay? Fundamentally understand why the maths is being done. And ideally, if you join the Discord, you can literally post questions and I'll answer them throughout the week. Right? But also use these live streams that I'm doing as well, right? Like, send in the question, I'll go through it, and if you don't understand, I can explain it to you, hopefully. I only got 2 marks this because I've got the... Yeah. Tricky. "3D trigs never fun." Never fun at all. That's okay, Caitlin. You said 1 was a non-square number for the Venn diagram. You know what? That's not the worst mistake I've seen. I've seen people say that 2 isn't an even number. So, it happens to the best of us. I think she understands that, Tenzin. This question was very similar to some of the questions we did. Very similar. In fact, I think the numbers were the only thing that was different. I said he, didn't I? My bad if I didn't. I meant to say he. Let me just see the question. Was it below or above this? The frequency polygon question. This one. Yeah, so you're not supposed to connect the line to the x-axis. So you might have dropped a mark for that. Oops. Yeah, so you may have dropped it. Yeah, so with a frequency polygon, you never connect the line to the actual axes. Damn it. Bit of an oof, yeah. So actually, let's scroll through it slowly but surely. Again, if you want to submit questions, feel free. If you want to ask anything, go ahead. Okay, so actually I've got some submitted. Okay. Okay, we're going to try out some of these submitted questions that I got sent in. So the first one is... So these are some probability questions. That's exciting. Okay. So the type of question that this is something called probability equations. Okay. So let's go through them. Okay. There are some red and some blue counters in a bag. The ratio of red to blue is 3 to 1. 2 counters are removed at random, and the probability that both the counters taken are blue is 1 over 20. So you know the relationship with the graph. You've talked about the relationship about the weight and age degrees, etc. Oh, that's fine. So when they say discuss the relationship, you don't need to say correlation. The only time you have to say correlation is if they say describe the correlation. So yeah. Okay. 2 counters are removed at random. The probability that both the counters taken are blue is 1 over 20. Okay, so here's what I would do. I would add an x to both of these. So we have 3x to x. The reason being is because we don't know how many counters are in total. Okay? We don't know how many there are. So there's 3 parts are red, 1 part is blue. So I'm going to call it x, okay? Which means the total is 3x plus x. There's 4x counters in total, okay? Hope that makes sense. Now, it's telling me that 2 counters are removed at random. The probability that both are blue is 1 out of 20. So what's the probability of getting 1 blue? Well, that would be the number of blue counters, which is x, over the total number of counters, which is 4x. Right? Again, stop me if this doesn't make any sense. He then takes another counter, so I'm going to times. And what's the probability that the next one taken is also blue? Well, there's x blue counters, but we've already removed one, so that's minus 1. And that's going to be over the total minus 1. So 4x minus 1. And that should equal 1 over 20. Not over 3. Not over 3. We've taken 1 away, which is from 4x. So it's 4x minus 1. Okay? By the way, something cool that we can do, I keep saying cool, I'm sorry, it's not cool, is we can actually cancel out the x's in the top and bottom. How? For this second fraction. By the way, I know there's a bit of a delay, so if I'm like not making sense, that might be why. From here, let's times the fraction. So 1 times x minus 1 will just give us x minus 1. 4 times 4x gives me 16x. 4 times minus 1 gives me minus 4. Equals 1 over 20. Now, I don't know how good you guys are at manipulating algebra, so I'm going to do this in 2 steps as opposed to doing it in 1 step, okay? So if we times everything through by 20 to get rid of the fraction on the right-hand side, I would get 20x minus 20 over 16x minus 4 equals 1. And then to get rid of the fraction on the left, because I hate fractions, I'm going to times the left-hand side and the right-hand side by 16x minus 4. So that gives me 20x minus 20 equals 16x minus 4. So you can probably see what we're doing here. So yeah, Nazza, exactly. All we're doing is cross multiplying. So you could jump straight from here, straight down to here. You could do that. But I wasn't sure if everyone knows how to cross multiply. Okay? So you can just jump straight ahead. But I did it in separate steps, okay? How comes you don't use probability trees? Won't you get confused? That's a really good question. So that's something I should probably point out. Is in this question, drawing a probability tree is 100% acceptable. 100%. So you would choose, you'd write, you know, blue, red. So probability of getting a blue would be, in this case, 1 out of 4, right? Because it's x out of 4x. So that'd be 3 out of 4. And then you do so you can do this. It's just that I find that it can sometimes be a bit too tedious, right? It takes a bit longer because then you have to write down all these different probabilities. But you're 100% correct. You 100% can. Yeah. Anyways, I want to rearrange for x because that's what I care about, right? So I'm going to minus 16x from both sides. So you get 4x minus 20 equals minus 4. Add 20. 4x equals 16. So x equal to 4. Now that isn't what they're asking for. They want to work out how many counts are in the bag. I have x equals 4, but there's in total 4x. So that's 4 times 4, which is 16. That should be the total answer. Yeah, probability trees would work as well, just as easily. Maybe a bit tedious, but other than that, it's completely okay. And I'll go to the next one in a second just to make sure everyone's alright with that. So you know for the scatter graph where they ask for the weight and you have to draw a straight line. I did a line starting from the origin. You may get 1 mark, but that method is wrong. Because you're not supposed to start from the origin when you have a scatter graph. Like a line of best fit doesn't have to go through the origin. In fact, most of the time it won't. So that's why. Could you use two-way tables? No. Two-way tables work for unconditional so this is conditional probability, so it doesn't work in that case. I'm the reason you're going to get a 9? I hope so. That'd be very nice. I hope you do get a 9. Yeah, you wouldn't normally use two-way tables for conditional probability. Edexcel High Paper 1 has traumatized me. I need a 6 and I'm not sure if I can do that. I don't know what to do. Okay, well, Mrs. Malfoy, best thing you can do is continue to practice, because don't forget, the first paper is only worth 1/3 of your grade, which means if you want to get a 6, in the next 2 papers you can get up to a grade 8 if you get 100%, right? Hypothetically. So you can definitely still achieve a grade 6. And that's just something you have to keep in mind. So keep practicing, keep doing papers, keep trying to understand why people do maths the way they're doing it in the mark schemes and on YouTube and stuff. And ask as many questions as you can. Do you think the grade boundaries would be lower? From what I've heard, people found paper 1 so they'll probably be roughly the same as 2019, maybe. But it depends on paper 2 and 3, right? So we don't know. Okay, so I'll go through this question as well. It's essentially the same as this question, but I want to make, that means, you know, it's good because that means we can make sure that we actually know what we're talking about, right? Yeah, you'd probably get a 9, yeah. That's what I'm saying. Like, you can get any grade still, technically speaking. It does depend on grade boundaries though. So again, what we're going to do is change this to 4x to x, which means in total we have 5x. Okay. So how many marks would you get for if you... Normally you would just lose 1 mark for the answer, but your method, you'd still get all the method marks. So you drop 1 mark. Who's going to get 18 out of 18? Yeah. So, 2 counts removed at random. Probability they're both a red is that. So what's the probability of taking a red counter? Well, there's 4x red counters. And in total there are 5x counters. So we can actually cancel out the x now. What's the probability of getting another red? Well, we've taken away 1 red counter, so it's 4x minus 1. And we've taken away 1 counter overall, so 5x minus 1. And that should equal 22 over 35. So now times the top times the bottom. 4 times 4x gives me 16x. 4 times minus 1 gives me minus 4. So probability, and even to a lesser extent vectors, they're actually easy to gain marks once you know what you're doing. But the problem is it's very difficult to know what you're doing. Right? So then we can do cross multiplication, as we mentioned before. I can do vectors if you want to submit a question, but I have actually got quite a few videos with a lot of vectors in them already. So what kind of vectors do you want to do? And I'll try and find a question if you'd like. That's completely fine, because I have them somewhere. Depends on the college, HAZ. Right, these numbers are a bit annoying, so I'm going to use a calculator, because, you know, paper 2 and stuff. 35 times 16, 560x, minus 140, equals 22 times 16, yeah, I don't need to do that. 352. That'd be 44 minus 88. God, why was that hard for me to do? Circle theorems was in paper 1. Do you think it'd be in paper 2? Probably not. They normally only need about 5 or 6 marks of circle theorems to be fine. Well, Midget, I'm sure a lot of people will actually appreciate it, so I don't mind going through another vector question. As soon as I finish this question, I'll find a vectors one. It's all cool. Yeah, anyways. Minus 352 from both sides, so... May you use a straight line? Yeah, sure. Can indeed. So yeah, I minus 352x, by the way. Can I go over the circle theorem one? It's the proof vector ones that are awful. I mean, I like vectors. Do I think shapes and graphs will come up? I mean, to an extent, yeah. How do you just know the steps for these? Good question, Kudos. To be honest, yeah, there is kind of a set method. But the way I looked at it is the only thing that you actually kind of need to remember is this bit here. From there, I've just used logic. So I've used the information that they've given me in the question. It says the probability both counters are taken a red. So I wrote out the probability of taking both counters as an equation. And then I've tried to solve it. And I just realised I made a mistake. Dang it. For some reason I wrote 16x minus 4 twice. Crap. Alright. Yeah, some of this is wrong. Oopsies. My bad. That should be 25x minus 5. So thank you for stopping me there. That makes sense. So 22 times 25 is 550x. See, that makes a lot more sense. Okay, cool. You're doing right now. By the way, I got the questions you're doing right now from Midstream. Yeah. So I think I did think that this was a Maths Genie question. So, but yeah, it's worth doing. Good question. So, what if you made it says 4x over x, which is the ratio of them? Would you do 4x over? Yeah, because it's probability. You need to make sure it's out of the total number of counters in this case, right? Which in total is 5x. That's why I chose that. So minus 550x. That gives me 10x minus 140 equals minus 110. So how many blue counters are in the bag? Blue is x, so yeah, that's how many blue counters there are. Koi, you're not wrong, but that would be if it said something like this. If it said something like 4x to x equals 25 to 10, then you would say that 4x over x equals 25 over 10, or whatever it says. Okay. As for vectors, I don't know if you guys have done the vector proof questions from Maths Genie, but we can go through some of those if you'd like. So if I open up these questions here, we start from the end because we're obviously god tier elites. Hardest topic for maths. I think for most people it's vectors or probability. So yeah, I think this question's actually not that difficult. So yeah. So if you want me to do any of these, just let me know. Good, Koi. Perfect. Well done. Like I said, once you know what you're doing, it's the same. There's two tricks. Pick the one that I think is hard. There's definitely going to be a 6 mark on vectors. I think that's a reasonable assumption. You know what? We can probably do all 3 of these. So I'll do the hexagon one. The hexagon one? Alright. It's fine if people... Yeah, finding vectors challenging is not like... It's not rare. Okay. Give you a 20-second head start. That's fine by me. I need some water because my throat is killing me. As you can probably tell from my... And I got another question that's submitted, by the way. It's a very interesting question. Since when they can use any shape they want. Yeah, via email. So I'll put my email in the chat one more time. And don't forget, by the way, guys, just for those of you that are here but not in the Discord, I'm going to be doing last-minute revision live streams the same time, so 6 p.m, next Tuesday and the Tuesday after, okay? So, if you submit stuff between now and then, I will go through it in the live stream, okay? And we'll go on as long as humanly possible. But yeah, just so you're aware. Spread the news if you want. Yeah. Okay, I'm bored now, so I want to start doing this. But yeah, just so you're aware for that live stream, you can. Waiting for that paper 2C. Should be out tomorrow. Hopefully. I did 2B today, that's out, so that's all good. I'm hoping. Anyways, let's start. So I haven't actually even read the question yet. X is the point on AB extended. Okay, so X is somewhere I'm going to extend it quite a bit over here, such that the ratio of AB to BX is 3 to 2. I got 56 on foundation and need a 5. 56 ain't bad. Okay. Prove that E, M, and X. So, yeah, that's a straight line. On the same straight line. Okay. So here is exactly how I would do this question, okay? What you're trying to prove when you say they're on the same straight line is that E to M is a fraction of E to X. So I should be able to write E to M as some fraction of E to X, okay? And I like to call this letter K. So where K is just some fraction of E to X, okay? That's all it is. So how do we work this out? Well, what we're going to need to do is we're going to need to work out an equation for E to M and, exactly kudos, prove they're on the same gradient. And I'm going to work out a expression for E to X, okay? So, do we need lines above the letters? Technically, yes. Technically. So, let's work out how to get from E to M first, because I think that'd be the easiest one to do. So, to go from E to M, here's what you need to do. You need to go from E to O, O to B, and then B to M, right? Because don't forget, with a hexagon, these lines here are actually parallel to each other. So this here is A, and this here is B. Because they're the same kind of length. So to go from E to M, I need to go from E to O, O to B, so that's 2B so far. Plus, I need to go from B to M. Ooh. All the sides are the same length. You're completely correct in that assumption. It's like E to D is minus A plus B. You can do that, yeah. That's one way to do it. When I say parallel, I mean they're the same value, right? So going from E to O is the same as going from O to B. And going from A to O is the same as going from O to D. And so on. Because don't forget, this is a regular hexagon. All of the sides are the same length, okay? Probably vectors or probability. So far, is that okay? And now we need to get from B to C. So it's a half B to C. Now how do I get from B to C? That's the question we need to be asking. Okay? Well, so it'd be 2 minus A plus B plus, or for E to M. I mean, it'd be 2B, half A, minus A plus B. Okay, these are good suggestions so far. Minus A plus B would be kind of what A to B is. Unless you mean from here. So, these are all good suggestions. So, in this case, so what we're going to do is we're going to say that this side here is actually parallel to this side. Right? So those two lines are parallel because, again, that's just a property of the property of hexagons. So to go from B to C, you need to go minus B, minus A, plus B. Okay? So it's just minus A. Okay? So it's 2B minus a half A. And that's how you go from E to M. So again, just to go through it again, to go from B to C, you need to go from B to O, which is minus B, then O to D, which is minus A, then plus B. So in other words, it's going to be just minus A. Cool, that's exactly what I'm doing, right? I'm finding EM, and then I'm finding EX, and showing that they're multiple. Right? Now let's work out E to X. In fact, this is actually going to be slightly easier, right? Because we're going to use a little trick for ratios. Okay? if I have a look at this, right, a to b is 3 parts and b to x is 2 parts. Okay, so what we can do is if I work out a to b, well, first off, e to x is just going to equal, it's going to be b plus bx, right? So 2b plus bx. Now bx is just going to be 2/3 of ab, right? So ab is minus a plus b. Okay? Yeah, this is EM. It's not the final answer. We need to actually show it's on the same straight line. Okay? So, that AB is worth 3 parts of the total line, which is 5 parts. Right? So, a few different ways you can do this. You can divide this by 3 and then times by, like, 2 if you want to. But BX is 2/5. Yeah, exactly. So BX is 2/5 of the line. And this is what 3/5 of the line is. Right? So, what's the best way to write this? Okay. So, this is 3/5 of the line. And BX is going to be 2/5 of the line. So what you can do is divide this one by 2 and then times by 3 to get what BX is. How did I get minus a half A? Okay, so for B to C, you need to go minus B, minus A, plus B. So can you see the only thing you'll be left with is A, right? BC is just A. Well, it's minus A technically. Well, the other thing is, by the way, is this line here is parallel to this line here. So it's just minus A. Let's go from there to there. But the other way to think of it is to go from B to C, you need to go minus B, minus A, plus B. Okay? Perfect. So, if I divide this by 3 and then times by 2 to get 2/5. So, 1/5 is equal to 1/3 minus A. Oh, okay, of course I can't do that. So then this would be 2/3 minus A plus B. So I can expand now. I get minus 2/3 A. And then we have 2B plus 2/3 B. So what is 2 plus 2/3? That would be 6/3 plus 2. Okay, so that's 8/3 plus 8/3 B. Hey Samantha, how are you? Hey Antonia, I do respond. It's just that the chat has a delay, so I might not see your thing straight away, okay? Perfect. Okay, so if I compare these two, right? Here's a little trick you can do. If you divide these by each other, so if you divide the number in front of A by each other, that will give you the scale factor, so the thing that you need to divide by. So, just because I'm going to be a bit lazy, actually, let's do minus 2/3, divide by minus a half, cancel out the minuses. So that becomes 2/3 times 2/1. So in other words, you can factorize out a 4/3 in order to show them that they're the same thing. So EM is just equal to 4/3 of EX. Okay. Of course you can send me a question, yeah. Can you go over the cards probability question? Which one is that, Antonia? You can email it in to me if you have it. But I do have another question from the old emails that I'm going to go through in the meantime. So this is another question that was sent in. It's a pretty good one. I can, Hannah, yeah. Finally. Even though YouTube has had my ads on my videos for months. But yeah, I can now. So, this question, which was sent in, is a really good question, actually. So, OAC is the sector of a circle. Right? And I didn't even know they had a predicted paper. Really? Interesting. Yeah. So just so you guys are aware, you can email in a question. And just for those of you that have joined recently, I'm going to do last minute revision sessions before the next 2 exams. So next Tuesday and the Tuesday afterwards at 6 p.m. So anything that I don't get through today, I'll go through next week. But again, you can email it in, okay? That's fine. Where's the paper? I'm just doing submitted question, Spytex. So yeah. Calculate the area of the shaded regions. This is a really, really good question. I really quite like it. The first thing that we can realise is that this overall shape is actually completely symmetrical. It's a kite. And the reason for that is that these are both tangents, and as a result, these are both 90 degrees, because this is a radius meeting the tangent, which means this is also actually 10 meters. Okay? Exactly, Koi. That's exactly what you're doing. So what we can do here is exactly as Koi actually said. That would be 60 degrees here, 60 degrees here. What we're going to do is work out the area of one triangle, double it, and then take it from the area of a sector. Okay? So what would be the best way to do this? Well, we're going to have to work out another side, unfortunately, but that's fine. We need half base times height, so what we're going to do is work out this side, since this is the hypotenuse. Exactly. So this side is our opposite, this is our adjacent, and that's our hypotenuse. So SOHCAHTOA. We want the opposite and we have the adjacent, so we're going to be using TOA. So we have tan 60 equals opposite, which is what we want, over 10. So the opposite is equal to 10 tan 60, which I'm going to use a calculator, but, you know. Not tan. Oh, crying out loud. Alright, 10 tan 60, which is 10 root 3. I'm going to leave it as that for now. Okay. So what we can do now is work out the area of just the triangle, this one triangle, and double it to get the area of this full four-sided shape. Spytech, we don't. I haven't even used it. I haven't used the length of that middle line, although we could work it out. So the area of AOCB is equal to 2 times the area of a triangle, half base times height. So half times 10 root 3. Right. So the 2 and the half will cancel out. That's fine. We will be subtracting in a second. So what I'm doing at the moment is working out the area of the full four-sided shape. Then I'm going to take away the area of the sector. Times 5 times 10 root 3. Which gives me that number. So 173.2, let's call it. Meter squared. And now once we've done all that, all we need to do is work out the area of this sector over here. And that's quite simple. A sector is just a fraction of a circle. Okay? I'll put my email in the chat, because I don't think anyone else could do links yet. So the area of the triangle minus the area of the sector. Exactly. Well, the area of the full four-sided shape minus the area of the sector. This is higher, I believe. It was a sent-in question. So, the area of a sector is just a fraction of a circle. And to work out the fraction of the circle, all we need to do is take the angle over 360 and then times the area of a circle. So obviously this is going to cancel down to a third. Okay, so 1/3. Whoops, that's 2. That would just be, so 10 to the 100, so it'd be 100 over 3 pi meter squared. And then all we're doing is subtracting these. So Spytek, it is an irregular shape, but what I did is I divided it down the middle, worked out this area, and doubled it, because both of these triangles are congruent. Because this side is 10 meters here, these two are tangents from the same point, so they're the same as well. And they share the same third side. So the shaded area is just 173.2 minus 100 over 3 pi. Congruent means the same shape. You're exactly right. That's correct, Leo. (68.5 square meters to 3SF). Yep, we found this side using trig. A good link for predicted papers is this link over here. Although it is Edexcel, I have to say. You can use half AB sine C for right angle triangles, but you might notice that the sine 90 should just be 1, which is just half A times B, which is base times height, right? So yeah. Oh, that's perfect. Then that link's all Edexcel, so that's all good. Yeah, half AB sine C is the same as half base times height. But when C is 90 degrees, right? Sine 90 is 1. So yeah. Oh wow, there's a lot of questions. Alright. Yeah, the countdown thing's a bit scary, but try and ignore it. Okay, so keep in mind, we're not going to get through all the questions today, but next week, right before the exam, we're also going to go through questions. Okay. So let's see, the next question was sent in. Oh, I see. Okay, yeah, great. Okay, I remember this question. I have gone through this in a video, I'm pretty sure. You're welcome. Yeah, that should be fine. We'll probably go through this and then we'll finish it up. Yeah, I'm pretty sure I've gone through this one, right? Do I remember doing old spec past papers? Yeah, of course. Maths hasn't changed, so you can. Old spec past papers are completely fine. Yeah. So Actually, the way I did it is different. So you could find all the ways to make it even, right? And if you keep in mind that, so when you add two numbers, right? An odd plus an odd always gives you an even. An even plus an odd, or an odd plus an even, is always odd. And then two evens is always even. Right. It is possible to get a 9, yeah. You just need to get as many marks as humanly possible, right? When you're adding them, it does, yeah. Right? Yeah. So when you're adding numbers, two odds make an even, two evens make an even, and if there's a mix, it's always odd, right? So yeah. So the way I would do it is, if you're working out the probability as even, do this first. So what's the probability of getting an odd number? Well, how many odd numbers do we have? We have 1, 2, 3, 4, 5. So 5 out of 9. What's the probability of getting another odd number? Well, there's one fewer odd numbers, so 4 out of 8. Which gives you 20 out of 72. And the probability of two evens, so how many evens do we have? Well, we have 1, 2, 3, 4. It's 12. Add those together and you just get 32 out of 72. So this is even. So the next thing it says is, yeah, so, well, hold on. So for this, I'm not done yet, right? Because like you guys have said, there's 3 cards, right? But this is still needed, right? All you have to do is, now we have 2 evens. Hang on, how do I... If I go back a step, this is how we get even numbers, right? So both of these are even numbers. So both of these give us even numbers, right? If we want to get an even number after this, we would have to do another even number, okay? So what we'd have to do is add on the probability of getting, well, times the probability of getting another even number afterwards. I think for the rest of the questions, because my voice is going to commit suicide in a second, we'll leave these for the next week live stream. But again, next week, 6 p.m. on Tuesday, I'll be doing a revision session. We'll probably go on until about 8 o'clock. My voice is giving out, so we'll definitely get on to that as well, okay? So, Naza, that's a good question. The reason why you can't is because 2 odds would make an even. When you add another odd, you would get an odd number. So that isn't a possibility. You can do the 1,000 practice papers on that website I sent earlier. But yeah, Nazar, I hope that makes sense, by the way. Cool. Because 3 odds actually make a odd number. Yeah. Yeah, we'll start a bit earlier. We'll probably start about 5:45 and we'll go until about 8 o'clock. That'd be it. So the answer, you'd have the times on the probability of getting another even. So right, so that's what we have at the moment, but we need to times the probability of getting a third even number. Okay? So once we've taken 2 cards out, what's the probability of getting an even number? Well, we've got 2 fewer cards, so that's going to be over 7. And how many evens are left? Well, if we've taken 2 evens already, there's going to be 2 left over, right? So times 2 over 7. So 64 over whatever that is. $504. And that simplifies down. Okay? And that will simplify down to get that answer. But yeah. Anyways, yeah. So hope you guys have a good rest of your half term. And again, same time next week, about 5:45 to about 8 o'clock. I'll go through the rest of the questions you've submitted. But again, feel free to submit more questions if you'd like.